Input output management and disk scheduling I/O devices. Generally, when the computer uses input or output devices as external devices, they are grouped into three categories. Human readable, it is suitable for communicating with the computer user, example printers and monitors, video display, keyboard and mouse. Machine readable, it is suitable for communicating with the electronic equipments, example device drivers, USB keys, sensors, controllers and actuators. Communication, it is suitable for communicating with remote devices, example digital line drivers and modems. There are many types of devices that work with the computer system. These are devices such as disk, tapes, network cards, modems, screen, keyboard, mouse, and many more. In order to communicate with a computer system, device sends signals through wires, or signals can be wireless. So signals can be through the wires or it can be wireless. The device exchange information with the machine with the help of connection port. If many devices are using a common wired communication, the connection is called as a bus. So organization of the input-output function. There are three ways to perform I/O. Programmed I/O, interrupt-driven I/O and direct memory access. So what is a programmed I/O? In this I/O is the CPU carry out all work. So in this, what happens? The CPU is carrying out all the work. Programmed I/O is straightforward but has a drawback of tiring up the CPU permanently until all I/O is done. The CPU issues an I/O command to an I/O module and then the process waits until the operation to be finished before proceeding. Next is interrupt-driven I/O. When CPU issues the I/O command in support of processes, two possibilities exist. If I/O instructions issued by the process is non-blocking, then the CPU keeps on executing instructions from the process that issued the I/O command. On the contrary, if the I/O instruction is blocking type, then the next instruction that the CPU executes is from the OS. As a result, the current process goes in a blocked state and schedules the next processor. Next is direct memory access. The data transfer between the main memory and the I/O is controlled by the direct memory access module. So data transfer between the main memory and the I/O. The CPU issues request for transfer of a block of data to the DMA module. In this case, CPU cannot be interrupted until the complete data is transferred. So until the complete data is transferred between the main memory and the I/O module, you cannot interrupt the CPU.